All right, so we are getting into our geometry unit. Here's our objective. Students will be able to find the area of right triangles, other triangles, quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes in order to solve real-world and mathematical problems. So quite a few new words here, some brand new, some you've heard before, like last year in math. We know that area is the space inside a shape. Okay. A right triangle, we know right here is specific because it has a 90-degree angle. Triangles in general are polygons with 3 angles and 3 sides. Quadrilaterals have 4 angles and 4 sides. Polygons are kind of that larger category. It's a shape that has 3 or more sides. And then composing is something we use where we're putting together or forming a larger shape around a shape in order to find area. And decomposing is when we're breaking these shapes down in order to find area. So let's go ahead and let's look at lesson 1 in module 5. The first thing we're going to do is we're going to be just looking at 5 different shapes and naming the shapes. So this first shape is a right triangle because it has this right angle right here. And we know that if it is a right triangle, it's always going to have that box for the angle. So this is a right triangle. Getting used to using this thing. Okay. The next shape has 4 sides and 4 angles. This is called a parallelogram because all the sides are parallel. Okay. This next one we know is a triangle. And if you notice, it's a specific kind of triangle. All of these angles here are less than 90 degrees. So this is specifically called an acute triangle. This we know is a rectangle. These 2 sides are the same length. These 2 sides are the same length. This is a rectangle. And then this last one where we have 2 sides that are parallel and then 2 sides, these 2 sides, if we continued them on forever, they will eventually cross over. This is a trapezoid. Okay. Today, what we're really going to be looking at is we're going to be looking at parallelograms, and we're going to be looking at how to find the area of a parallelogram. So if we look closely, a parallelogram is very similar to a rectangle. It's just a little bit shifted. So if we look here at this, we see that this is a rectangle. This is a parallelogram. So notice rectangle, parallelogram. So if we take kind of that shifted side over and we move it, we don't change anything about the shape, we just move it over to the other side, we end up with a rectangle. So to find the area of a parallelogram, we do the same as when we find the area of a rectangle. We do the length times the width, or in this case, we start calling it the base and the height. So the base is the bottom, and the height is the line that goes from the bottom of the parallelogram all the way to the top. The important thing to know about the base and the height is they're always going to form a right angle together. So if you notice the side on the left cannot be the height, this one right here, because it is slanted and it does not form a right angle with the base. So this here is our height. Even though it's not one of the sides of the shape, it's the height because it forms a right angle with the base. And again, if we see this movement, we see if we take that and we move it over, this was the side that was in the middle, and this is the height. So the length and the width are the base and the height. So we're going to go ahead and we're going to look at an example. All right, and it says find the area of each parallelogram below. Note all figures are not drawn to scale. Okay. I'm going to zoom in a little bit here because I just want us to look at this A together. Okay. And remember, area of a rectangle and area of a parallelogram, we use the same method to find them. But like I said, in this case, instead of calling it length and width, we call it base and height. So the area is equal to base times height. So BH means base times height. Because remember, when there's no operation symbol, it means that they're being multiplied. So now we need to find the base and the height. So if we look at our parallelogram, remember we said that the base and the height are going to form a right angle, a 90-degree angle. So this cannot be our height because it does not form a right angle with the base. So our base is 6 centimeters and the height of this is 4 centimeters. Okay? So even though the 4 centimeter line is not a side of the shape, it is part of the shape because it shows us the length from the bottom, the lowest part in this shape, to the tallest part in this shape. And if we were to move this side over to the other side, if this is 4, then this is also 4. So that helps us to kind of see the height is 4. So the area is equal to the base, which is 6 centimeters, and the height, which is 4 centimeters. Okay. Then all we're doing is we're going to multiply those together. So the area is equal to 24. And then notice we're multiplying centimeters by centimeters. Remember, this goes back to what we learned. If we are multiplying 3 times 3, we can write this as 3 squared. So centimeters times centimeters is going to be centimeters squared. So the area of the shape in A is 24 centimeters squared. Now, when you go through the examples, I do want you to write all these steps. Even if you can easily see it, I want you to write the formula. I want you to substitute. And then I want you to write your final answer, just so we get in the habit of using this formula to solve for area.